Hello students, I hope you are fine. Let us start our task. Now let us revise which things are being taught till now. You know, we have studied about the ratio of sides to particular angles. We have also studied about what their relations is there, sine to cosec, cos to sec, tan to cot, sine and cos of tan theta, cos and sine to tan theta, cot theta. In this way we have studied. Now it is not the ultimate. Now we have to study about the basic identities, which one is very essential for our studies. These are helpful in proving different identities, different problems. So how can we solve? It is discussed here now. So we have to solve such type of identities, and we have to verify here with the help of Pythagoras theorem. I hope you will appreciate it, you will understand it, and you will follow it. So let us start without delaying or without wasting time. Let us start our task. So now we have to start. Students, you know which type of triangle is it? This one is a right angle triangle. What is the name of triangle? That is triangle XYZ. And this one is right angle. That's why this triangle is a right triangle. What type of triangle is it? This one is a right triangle. This one is 90 degree. So, and this angle is of theta. This angle is theta. This one is perpendicular. This one is base, and this one is hypo. We have discussed earlier. Let us see which identity is the first identity of basic identities. The first basic identity is sine square theta plus cos square theta equals 1. How can we prove this? This is an identity, and we have to prove it with the help of Pythagoras theorem. And I have mentioned you, every time where there is a right angle triangle, we take which type of theorem? That is always Pythagoras theorem. With the help of Pythagoras theorem, we apply in right angle triangle. And what is Pythagoras theorem here? In right angle triangle XYZ, a square plus b square equals c square. What is c here? C is the longest side of right angle triangle, and we have studied in class 9. Hypo is the longest side of right angle triangle. So hypo is greater than base, and hypo is greater than perpendicular. So a square plus b square equals c square is the short form of Pythagoras theorem. What is a base square or square of base plus square of height or perpendicular equal to square of hypo? C square means square of hypo. A indicates b, base, b indicates perpendicular, and c indicates hypo, because this one is the longest side. Now base square plus perpendicular square equal to hypo square. This is Pythagoras theorem. Now what is base here? Base is yz. In the place of base we have to write down yz. Yz whole square plus what is perpendicular here? Perpendicular is xy So in the place of perpendicular, I have noted down here xy. You mark in the place of perpendicular it is xy. Since a square is there, so that will be xy square. What is hypo here? Now observe, xy is hypo. So in the place of hypo, we have noted down here xz. And since hypo square is there, therefore this will be xz square. Now this will be behaved as equation number 1. How do we obtain this equation number 1? Can you recollect it? On the basis of Pythagoras theorem. Now see, yz whole square plus xy whole square plus equal to xz whole square. Now this one is equation number 1, and this equation number 1 will be divided by xz whole square. An equation is divided by any quantity. It is remarkable here to understand the left side is divided as well as right side both, because an equation contains two sides. If an equation is divided by any number, so that number will divide left hand side as well as right hand side. Since this equation number 1 is divided by which one? Xz square, so it will divide left hand side as well as right hand side. See, yz whole square divided by xz square, again xy whole square divided by xz whole square equal to xz whole square divided by xz whole square. What is difference between this one and this one? This one is without division and this one is after division by xz whole square. Now see, this one whole square upon this one whole square, this one whole square upon this one whole square, this one whole square upon this one whole square. In powers, we have studied a kind of law. If p to the power m upon q to the power m is given, so that will be equal to p upon q whole to the power m. Now this power is common here, so this will be noted down yz upon xz whole square. This 2 is common there, so common power is written only once. Similar pattern here, xy upon xz whole to the power 2. Here also xz upon xz whole to the power 2. We have to apply here the law of exponents. And law of exponent means what? If fractional powers are common, so that will be noted down in a single power and it is represented in bracket, single bracket. So same thing is done here. Now this will be simplified. Xz upon xz, numerator and denominator both are equal, so that will become equal to 1 because xz will cancel to xz. Now this one equals 1. Now what happened? Yz. Now see, y and z, this is the value of base. See, yz is base. What is xz? See, xz is hypo. So this one is b for base and h for hypo. So b upon h and power 2 is as it is plus. What is xy? See, xy is perpendicular. So xy is perpendicular to p indicates perpendicular and xz is hypo. So perpendicular upon hypo whole square equal to 1 square, and 1 square equals, if 1 square is there, we can simplify 1 into 1 and 1 into 1 becomes 1. Now see, the ratio of base to hypo is what? Base to hypo. Base to hypo is what? Can you recollect? This is the ratio of cos of theta. Base upon hypo is the representation of cos of theta. So since b upon h is whole square, so this will be cos theta whole square, and that will become cos square theta. Again, this one is xy is perpendicular and xz is again hypo. See, xz is hypo and xy is perpendicular. Again, it is the ratio of perpendicular upon hypo, and we know the ratio of perpendicular to hypo is known as sine of theta. So in the place of this one, we have to write down sine of theta and whole square, and that will ultimately become sine square theta, and that is equal to 1. What happens? Here we have proved our result is there, cos square theta plus sine square theta equal to 1. Try to follow here. Either note down cos square theta plus sine square theta equal to 1, or it may be written in another form. What form is there? Note down sine square theta first and cos square theta. Afterward, because we know we have commutative line, we can note down a plus b as b plus a. So by applying commutative law, we can exchange the position. There would not be any difference because 3 plus 4 is equal to 4 plus 3. So we can change their position. There would not be any impact upon their position as the result. So this sine square theta will take first place, and this cos square theta will take second place. In this way, it will become sine square theta plus cos square theta, that is equal to 1. Now, the first identity, it is the one of the first basic identities. We have 3 basic identities, and this one is the first one, basic identity, and we have proved the first one. Now see, on the basis of this, we can establish 2 more relations by transposing the quantities. Cos square theta plus sine square theta is equal to 1. Now here, cos square theta will be noted down as it is. This sine square theta will be transposed to right hand side. So what will become? It will be cos square theta equals 1 will be noted on first, and this plus sine square theta to right hand side, it will become minus sine square theta. It means what? Cos square theta is equal to 1 minus sine square theta. Meaning is that as per requirement, in the place of cos square theta, what can be noted down? We can note down 1 minus sine square theta, or in the place of 1 minus sine square theta, we can note down cos square theta. We can apply it while solving the questions. You may observe when we are going to solve this type of questions, so we will use this type of relations. So directly in the place of cos square theta, we can note down 1 minus sine square theta, or 1 minus sine square theta equals cos square theta. We can apply it. So for this purpose, and this one is the source of this one. Again, it is not compulsory that we have to transpose only sine square theta to that side. We can transpose cos square theta also to that side. If cos square theta is transposed to right hand side, so what is remaining there? Sine square theta. So sine square theta is noted down here. Now cos square theta will be transposed to right hand side, and it becomes 1 minus cos square theta. Clear? So in the place of sine square theta, what can be noted down? 1 minus cos square theta, or in the place of 1 minus cos square theta, we can note down 1 minus sine square theta. So on the basis of this first identity, we have established 2 more identities which are very helpful in solving and calculating this type of identities, in proving left hand side equal to right hand side. So this one is very crucial, and now it is the turn to discuss about the second of the identities. And you know what is the second identity? That is, we have to show that 1 plus tan square theta equals sec square theta. What is that? We have to show that 1 plus tan square theta equals sec square theta.